everybody. Okay, for people joining this live stream, we are about to do a review of compiler functionality for future versions of Wolfram language. So, I haven't seen this for quite a while, and all kinds of things have been happening. So, Christopher, do you want to launch here?
Sure. So, so there are a couple different categories of new things. So there's declarations, which are things like, before you compile the program, you declare a bunch of functions or you declare some types or things like that. Then there's some stuff about how types themselves are represented, which often show up inside of the declarations. And then there's stuff about the functions that live in the actual compiled code itself.
You mean compilable code itself?
Compilable code, yes. So I think the place to start is declarations, because these are sort of prerequisites for the other stuff. So the first, for some reason everything's kind of laggy right now. I think it's because I'm sharing, but yeah. So so the first function, which is actually already in system but is undocumented, and its behavior is now totally different, is this one type declaration, which is kind of the lower level function for declaring a type. So honestly, I think that the main uses of this will be, first of all, like interfacing with external programs where, there are all sorts of exotic types that you might need to interface with. And then also, if you're sort of, this one I think is, if you're just trying to compile a quick program.
What does this mean? What does this mean? Is the word product here in the sense of our system function product, or is it some completely?
No, it's like a structure or a record. A struct, but it's got an algebraic name given to it, because
so we talked about maybe calling this struct, right? So this was previously called sum, now it's union. This one is still called product, but it could be struct or record or several other things.
So these are the
first argument is the type of thing you're declaring. It's not, so these aren't four different function names. These are four different types of types you're declaring.
And why have we decided not to have a thing called types product or struct or something like that?
Well, we talked about this, but I think that the basic, what we talked about before is basically how you could either have it so that there's a separate symbol for each of these different things, and there's sort of with the purpose of being able to do some sort of algebra with it and stuff like that. But basically the conclusion was that this is a little bit, the way this is set up, that kind of algebra, that sort of symbolic algebra doesn't really make sense. And so better just to have them all in one function.
And do we expect that there might be, because this is like from C onward, these are basically the names. At least, struct, union, whatever. These are basically type def. These are basically names that have, there aren't more than this, are there? There's another 15 of these that are like minority.
Well, there's a couple of other ones.
There are some more. Yeah.
There are some more. Yeah. So for example, right. So for example, there are a couple different ways you can do aliases. So actually there's already, I'm not sure this would be documented initially, but there's already one called macro. So basically this one is basically just anytime you see the name foo, you replace it with this, which is basically what a C type def does. That's as opposed to an alias, which is, I think, the more documentable one, which is basically saying, I want to actually new type, but I want it to be as its implementation, it will use integer 64 in this case, which is different because it means that if you have a function that takes a foo, you can have a function that either takes an integer or it takes a foo, and might have different behavior in those two cases. But if you have a macro, then it can't have different behavior. But this is probably the documentable one.
What is abstract?
In any case, abstract is for declaring an abstract type. This is basically otherwise known as a type class. Basically, this is like, you'd have something like numbers would be an abstract type. And that way you can have a function where you say, this takes any number, as opposed to saying it takes an integer.
Richard here is asking about dependent types. Do we have anything to say about dependent types?
Yes, we do have dependent types that depend upon terms. Yes, we do. That's further down. That's the type literal.
Well, but yeah, I mean, this is a more, it's not, yeah, I mean, we'll see how that works lower down. It's not like the full-fledged, you call absolute value on an integer 64, and depending on what the number is, it's going to return different types. So, or, you know, same with square root. So that's, it doesn't quite do that. It's a bit simpler.
Okay, but question up here. So, I mean, this is for building types. This type declaration thing is for building up types from simpler types. This is a type constructor concept.
Yes.
And how many of these, I mean, these types are going to get really complicated really quickly. I mean, are these things that users are going to see, or are they always just going to be, you know, hidden away?
So I think if you're compiling, I think so first of all, if you're not defining any of your own, you know, if you're basically just compiling a bunch of stuff that uses system functions, then you should never have to write any of these. I think then if you're defining a little bit of your own stuff, then you're going to end up using this thing, which is the higher level version that basically does a lot of this type declaration stuff automatically and in kind of a cleaner way, but is a bit more restricted. And which also can't really create types that interact with external programs. So this is the one that people will actually use, I think.
Okay, so maybe type declaration has some nice pretty print form in case you see it somewhere as something that you created, you know, one time in antiquity it was created and then people just used it from then on out. Is that a fair?
I'm not sure what you mean by pretty print form, but I mean, this is a low level function is the point.
All right, okay, fine. I think I understand what it does.
Right.
Okay.
It's like set doesn't have a print form. I mean, well, it has like colon equals. So I guess in that sense it does, but it doesn't have a nice box representation.
Right.
I mean, we do document some of these. There's a guide page of compiled types where we document various types. So,
although it needs to have a lot more types in it.
It's conservative in documenting things that are really concretely official. Yes.
Okay. Polymorphic declarations.
Right. I mean, so basically this is just a syntax thing for, you know, well, okay, there's a few pieces of syntax here, but the main piece is, but basically this is the case of if I have a struct and, you know, it contains, you know, two fields that are the same type, but that could be any type, or I have a struct that contains, you know, one number and one list, but it could be any type of number, right? Then this is sort of the syntax for that. There's also, I'm implicitly using this thing here, which is equivalent to this here. And we've talked about this a lot before. Lower down, there's a proposal about a special piece of syntax for kind of avoiding this.
Why is the product type up there? Why is that not an association? The payload of the product type?
It could be. I'm not sure whether it's better for it to be an association or a list of rules. There's another place where this kind of comes up, and either way they should be consistent. But I think
it could be. I think it could accept an association. I think that would be totally,
because those are unique field names.
They are unique.
Yes.
Correct. Yes.
Okay, so
there's one reason why not is in principle you can have these things without names. So we don't really use that, but in principle that's feasible.
That's a good reason to not have them.
But then you would just have T and real 64. So
yeah, right. But can you have some with names and some without names?
I don't think so, because they'd either have to be positional or they have to have names.
Yeah.
I mean,
it's
like having an association where some of the things don't have keys. Right. Yeah.
I mean, I don't think that's so useful. Right.
Kind of the natural design thing would be it's either a list, in which case it's positional, or it's an association, in which case it's got keys.
Yeah, I think that would make some sense.
Okay, so let's see this constrained type. By the way, I assume who is PMing here? Is it Aubrey is PMing? Yes, and so
yes,
and you're taking notes on these various items. Yes.
Yes.
Okay, good. All right, so let me try to understand this thing here, the type declaration with this T element of numbers.
Right. So basically the point is that if you have a polymorphic type or sort of a parameterized type, then it means that type will take various arguments. And the syntax for that is you either write, foo, and then it takes some arguments, foo of integer 64, or maybe I'll use a concrete example, packed array of integer 64, and then it takes the rank. So it's a rank, it's a matrix of integer 64s, for example. There's an alternative syntax which is this sort of shorthand, which again I think we'd like to escape using some sort of maybe special syntax stuff that hasn't been implemented yet, which is like this. But either way, the point is that basically what this is doing is it's declaring that we're going to have a type that's foo of something, and we're going to have maybe some constraints like that something has to be a number, and then this is the set of fields that we're going to have in that type.
But so if that thing was the integer 64 thing there, what would the let's say that was T was the thing which is filled in packed array as integer 64. What would the element of thing say there?
The element, you mean?
In other words, let's assume. Okay, when you write the type declaration for packed array, instead of foo, put packed array.
Yeah.
Right, the type declaration, right. So sure, right.
Okay, so now
what? Something like this.
Okay.
Then this constraint doesn't. It would be something like
I think
packable.
it's base packable. I think actually is the.
Sure, but yeah, I mean, some abstract type that's defined somewhere else, and then for your fields it'd be something like
What about R? Isn't R an integer? So is there a list of?
No, R is not an integer. R is a type literal, which we'll see later. I mean, so the point is,
don't you have to declare what happens if you had two types in the packed array? In other words,
if I wrote integer 64 comma real 64,
for example, it was a T and a U.
Right, the program wouldn't compile.
Why?
It wouldn't be specified because basically
there's no declaration of packed array that works with.
Yeah, exactly.
With
there are no functions for packed array.
It just wouldn't find a type that matches that.
No, I understand, but if it wasn't packed array, if it was some newly introduced thing which had two parameters, both of which could be types, is that possible?
Yes,
yeah,
that's
sure,
exactly so.
Sure.
As many as you want.
Then that third argument will be a list: T element of base packable, U element of something else.
Yes, correct. Yes, you're right.
Right. I mean, you could have something like
it depends whether you want to put a constraint on it or not, but
you could have like say a hash table that goes from the type of the keys to the type of the values.
Right. So then you would say T1 goes to whatever.
Yeah.
No. Yeah. I mean, this is how if you wanted to have a pair, this is one way you could do it. Something like that.
You wanted them to be
these are any two types.
Right.
I am utterly confused here. Why is there not a third argument like there was above with the constraints?
Because in this case, I'm not imposing a constraint. I could impose a constraint. But in this case, I'm sure I'm just talking about a pair, right?
Okay, but fine. But if you
any T1 or any T2.
Okay, but let's say you did want them to be constrained. I'm just trying to understand the syntax.
Yes.
Then there'd be a third argument there, which would be T1 element of blah blah blah, T2 element of blah blah blah.
Correct.
Exactly.
Correct. Yes, exactly.
Okay. All right. Fine.
And I think you can either write a list or you can write with and stuff. But yeah.
Oh, you can write it with and. So this notion that type containment is represented by element of, that's a thing, and we're safely doing that. Is that correct?
Yes.
I mean, it's a little bit strange because this is a string, right? But I think that if we just accept that element this is just some little symbolic object, and I think that's perfectly safe.
So we're imagining that element of, like rule, is itself inert, but upon being, because we can perfectly well have rules with strings on the right-hand side. But so we're imagining that element of is sort of the next, is something like rule.
I think it's called element, not element of. But yeah, I mean, I think this is assuming that element is just a totally inert thing, which I think it is.
I think it is, yes. It should be.
right? I mean, it's primarily documented.
It is not inert, but if the domain is a string, then it is completely inert.
And when is it not inert, Rob?
Oh, try something like
There's an
element
example there
of
of-
x,
right.
positive integers.
Sure.
Oh, I see.
Huh. It's interesting though that this doesn't work. I mean, I guess it's the domain is not
put in
a
an
list.
x
It's
instead of a 1, and you'll see what it expands to as well. It sometimes expands.
maybe if I say some sort of function expand, or I don't even know what expand.
Just replace the 1 in n sub 2 with an x, and you'll see what happens.
N sub 2, the one that says one element.
N sub 2.
Ah.
Make it x.
Oh, the x. Yeah.
Right. Well, you did it the wrong way, but you got the idea.
Yeah.
Right?
I see. Huh.
That's a little scary.
Well, I'm not a huge fan of this, but you know, that's the way Roger and Adam have designed this stuff. So
okay. I have this feeling that we're going to end up with something where the algebra of element is not going to be a perfect fit for our sort of computational types, but we'll see.
Okay.
Right. I mean, in this, I mean, the way that the abstract type system works, I mean, there is some it's like a DAG, right? So, or maybe even no, it's a DAG, right?
It is a DAG.
So,
yeah.
So, I mean, I think that the like algebra of how, you know, being an element of a set is also kind of a DAG or a tree. So I think that is kind of okay. I'd be more worried just about the literal syntax of is this going to evaluate?
Yeah, I know. That's why I'm saying element might not be quite the right concept. Anyway, let's keep going. We've got lots to go through.
Yeah. Okay. Fine.
I get this. Okay.
So the next, well, actually, I'm gonna quickly rearrange these. So the next one is basically the higher level way of declaring types, which has several syntaxes. But the basic idea is this one is like I want to create a type and I want to have these fields and stuff like that. This one is there's some expression, there's some common pattern of expressions, and I'd like to be able to, create a type that sort of efficiently represents that common pattern. So for example, let me skip to this example. So this would be, for instance, declares a type called undirected edge, which represents, a thing with head undirected edge where both of its arguments are integers, for example, right? Yeah. Or, this declares an undirected edge where, it takes a single argument and, it has two slots that are the same type or something like that, right? And the point is that
completely getting this. I'm not completely getting this. So this is, what does this do? Is this
so what this does? What it does is it says, let's say, this is a common. Let's say that you have a million. Undirected edges containing two integers, right? Yep. You can imagine, if you have a big graph with integer vertices, you might have, a billion of these, right? And in compiled code, one way of representing them is just representing them using an expression. But that's not very efficient for, both because it has to disassemble the expression, because the expression isn't very, you can pack it more efficiently and so on. So basically what this does, when you write compiled expression declaration of undirected edge, comma, this, what it does, it declares a type product and it declares a whole bunch of other functions that go along with it, so that basically for the purposes of your compiled code, you basically have an efficient struct which represents this object, but it represents it as a struct, not as an expression.
So in other words, when you compile it, it will be turned into this raw thing that you have declared here.
When you pass it into or out of, it puts it into or takes it out of. So it integrates it with the evaluator.
How does this relate to our data container concept?
It is very related, because basically if you have a compiled, struct representation of a type, it means that at least my understanding is it means that basically you can put it into the, Rob's prototype data container stuff.
Rob, can you speak to that?
Yes, I think this is actually a huge possibility, and that's a phase of work I haven't done yet. But I'm looking into what sort of types we could support, with little compiled libraries or things like this that would give us a lot more flexibility than.
But so what you're doing with data container right now is the destination is packed arrays and things. Is that right? Yes,
the destination is packed arrays and numeric arrays, but I think there's.
I see. So this will be a way of having a customized destination.
Right.
Cool. Okay. On which certain operations might work and many would not, because you would have to, given the data structure that you're going to use for undirected edge, you have to have a whole, flotilla of functions that work around that.
Right, but that's what this function here does, basically, is that it defines, once. So if you just declare a type product, called foo, now if I want to construct this foo type, I have to use this lower level function, or if I want to extract this field, I have to use this lower level function. The point about compiled expression declaration is it declares sort of all the functions that make it look like you are actually using, like something on the top level. So for example, if you want to construct it in compiled code, you just run undirected edge and then give it some arguments and it will construct one. Or, if you
part extraction works.
Part extraction works. Asking for the head works. Asking for the length works.
What about something like reverse? Would reverse work?
Reverse doesn't work, and reverse can't work in general. It could work in some cases. It can't work in general because
I'm not sure it's a good idea. I'm just trying to understand. There's a certain set of type poking functions that can work.
Right. Here's an example where you would add functions. So I did this business with a round, I don't know, over a year ago that gave us, like a factor of 50 speed up. And it would have been much easier to do with this system, but I would have still had to add some functions to do the basic arithmetic for a round, because that's sort of not something that applies for every expression. But the coming in and out of expressions would have been pretty much automated by this.
Yeah.
Okay, but so the thing I'm trying to understand is usually we have things that are opaque atomic objects that can only be poked and peeked at in very specific ways. This is something where you're saying declare something as an expression, which normally would be manipulable at all levels. But what this will do is it will declare it as an expression which allows only a limited set of intrinsic operations on it. Is that a fair statement?
In compiled code.
In compiled code.
Outside of the compiler, you can do what you want. It's just a regular expression, a regular normal expression.
Yes, right.
I mean, there's a certain amount of floppiness that you can't, there's crazy things you can do with expressions where, you map all some crazy function over it. And, it applies to the head and gives you some other crazy expression. And that can't be compiled.
So these are pseudo-atomic things, except that certain operations work just as they do on typical, on a sparse array or some other atomic thing. And what we're saying is that the compiled expression declaration is creating kind of, so you might in general have something perhaps analogous to something that would happen with data containers, where you can declare some particular additional functions, and Rob might have done that with a round, that will work on a certain kind of compiled expression. Is that right? Just like there are generic ones that will work. And do you have a mechanism now for how to specify those additional functions or not?
Well, it's function declaration. So once you have this type, you can just write a function declaration that takes that type and calls part and does whatever you want.
It creates a type called undirected edge, and you can write any compiled code that works in the type undirected edge.
Yep, I get it. Okay, very nice. Okay.
Right.
Okay, so this is essentially saying, how is undirected edge going to be laid out in memory? How is this thing that at top level is called undirected edge going to be laid out in compiled code in memory? And the thing that you can put on the right-hand side there is, so integer 64 is a shorthand for a type product. Is that correct?
Yes. This always makes, this pretty much always makes a type product. In this case, it's in the future, I think there might be some interesting things about representing, type sums and stuff like that. But right now there isn't the backend infrastructure for supporting that.
Right. Okay.
Fundamentally, you're basically just specifying a set of fields that it's going to have.
Right. Like an ordinary data structure without a union. in C or something.
Yes.
Okay, terrific. So those things there could be, for example, packed arrays of integer 64. There's no problem with that.
Exactly.
And it can be an arbitrary length. It doesn't care about. It's not saying
Yes.
this has got to be a fixed length record or anything. It deals with all.
Yeah.
You got it. And also, again, they can be polymorphic. So I can have, undirected edges of any objects, or I could have undirected edges of packed arrays of any objects, or whatever you want. Yeah.
The fact that you've named that right-hand side undirected edge, why did you, with the string? Why is that?
Okay, so basically this is, if we're getting into the full syntax here. Oh, I should have included the draft usage lines, but okay. So basically, the first argument is basically what is the head of the symbol that, what is the head of the expression that we're kind of trying to make a compiled version of. Optionally, and what this does, it will create a type with the name quotes undirected edge, because all types have strings for their names. So you can optionally give it a different name. I could call it foo. I wouldn't really want to, but I could. But basically in the polymorphic case, you kind of have to give it a name like this, because you need to be able to sort of give it this, in the same way as up here, you basically said that the type is foo of T, where T is anything. Here, the type is undirected edge of T, where T is anything.
But so that right-hand side, more fully as it was above, will be type specifier of undirected edge, whatever.
Yes, and that works also. Yes.
So, okay, so this means the undirected edge is really a type specifier. Okay, I think I get it. Makes sense.
It means that if you want to represent an undirected edge, this is the type, this is the name of the type that you're going to have, and this is the fields that type is going to have, right? Or basically, these are the types of the arguments.
I see. So if you were declaring, I see. So in the end, I get it. This is very nice. Okay, so basically the top level name is whatever the top level name is, and then the default internal name is just the stringified version of that name, and that is the thing that you would use in a typed, when you say typed.
Correct.
Yes.
You got it.
Right.
Yes. We have to think about context there, Christopher. We've talked about that, but
yes. There was talk about. One of the things I think is worth thinking about at some point is about having, instead of having types all be strings, having them be symbols, or making it possible for them to be symbols, because then you can have contexts and stuff like that. But there are lots of issues, because, for example, you'd like the type of undirected edge to be, if it were a symbol, it would have to be undirected edge. But of course, then
sometimes
the type will be, sometimes they evaluate, right? And so you can't really have that.
Okay, all right. So that's a bit. One could imagine a decorator. For the context thing is tricky. Okay, let's keep moving.
But okay. So there's another usage of compiled expression declaration, which is a little bit different, which is basically for so-called expression-backed or expression-based types. So the point is up here, basically, the expression was going to be, you tell it a lot about the structure of this expression, and then it's going to represent it with a struct. In this case, you don't tell it as much about the structure of the expression, and it's actually just going to represent it with the expr struct. It's going to represent it as an expression, but with a special name. So, for example, this would, for example, if I had something like list expression as a type, or maybe I'd have something like normal expression for any expression that has arguments. And then basically give it a function which it will use to test. When you give it an expression, it will use this function to test, is this really a valid list expression, or whatever you want to call it.
Okay, so in the first usage case, where you just give literals on the second argument, that is, so you're distinguishing two cases. One case is that is a test, and the other case is that is the layout in memory. So integer 64, integer 64 is layout in memory. Is there no syntax ambiguity between these things?
There's no ambiguity, because this one it's always a function. It might be a typed function. This one it's a list of
it could just be even q, couldn't it? It could just be that second argument, just be even q. The whole thing.
Well, it couldn't quite, because it actually takes two arguments, but even still. So the two arguments are basically this is the expression where you'd like to see if this is a valid list expression or whatever you want. And then this is the type. So basically this ty, that will be given something like, in this case, it'll just be given list expression, which isn't very useful and doesn't provide any
But if it was
additional information.
polymorphic, you might not know what the concrete type actually being given was, you see.
Right. So for example, if I had a list expression of t's, right? So basically this represents a list of integers or a list of real 64s or whatever. Then this function, in order to test whether this expression is a valid list of integers, it needs to know it's a list of integers.
Right. Okay. So it's a function of two arguments, but in general, which is just returning true, false, which in a sense conceptually is like your T1 element of numbers back up at the top of the screen there, which is again conceptually testing a true, false thing for that.
A little bit, but this is these T1s, these are like types. And we're making expression about types. This is values, but yes.
So the types execute at compile time, whereas the values execute at runtime. So that T1 element of numbers is known at compile time, and it'll either work or not work.
So this is a runtime.
This is a runtime thing, yes.
The cookie cutter runtime that tries to see whether it's working. Okay. Should we go on here?
Yeah. So the next one, this is the last of the new declarations, but this one's actually very, very useful. This is called library function declaration, and basically it's for, this would like to be kind of the library link obsoleter or something. Basically, what this does is it says basically you tell it, here's a library, here's a function in that library. And then it gives you access to a function that you can call in compiled code, which will call the library. So in this example here, basically I'm saying, okay, in libcrypto, in OpenSSL, there's a function called SHA-256. This is, by the way, a slightly fictional example here, but it's
okay, so that second argument would normally be a file path. Is that correct?
Yeah, that could be.
No. Well, actually, get rid of the .so. You just have the name.
Okay, so there's. Yeah. This is anything you'd feed to find library.
Correct.
I think that it would be good. There's sort of a thread along with this about trying to improve find library so that you can do things like write OpenSSL here or something. But that's better. Kind of a slightly separate discussion, I think.
Yeah. But you don't want to give a path there because it means your code is very non-transportable. You want to
I get it. So that's the thing where you're finding the library somewhere where programs find libraries on your computer.
Okay. And then we have a mechanism for this called find library.
No, right, I remember. Right.
But the reason why it's significant that it's OpenSSL and not a path is that it's going to create, if you compile a compiled code function that uses this thing, and then you transfer that compiled code function to someone else's computer, when you try and run it, it's going to look for OpenSSL. But if you gave it a path here, it's going to fail.
I get it. I get the point. Right. So, okay. So the third argument there is some kind of way
This is the type signature.
C. So this
is the type signature using lots of types that are basically, correspond to the types in C.
So those will be documented in our list of types, like integer 64 and so on. These are additional types that are C language types. Is that correct?
Yes. And you can kind of, all of them are it's C followed by the name of the type in C.
Except for array, which isn't a type in C.
Except for array, which doesn't really have a name in C.
Because it's just the open close bracket.
It's
or a pointer. Yeah.
And what is C size T?
It's a size T.
Type
size underscore T.
Right.
What the heck is that?
It's usually a long. It's like the size of a
It's the integer type that you use to specify the size of the object.
Right, like in malloc, for example.
Right, could be int, could be long.
There used to be a size of macro or something in C.
That's a different thing.
Yeah, it's the type of the return type of size of, I believe.
It's
size t is just a standard, like size t is just, in any I think since C89, size t is just basically like the biggest unsigned integer thing which you use for representing
and this
the size
is
of
our binding to C types, and we've made a collection of these. It's
okay.
pretty, actually.
That's nice.
It is nice.
Okay.
Yeah.
All right.
So basically, you'd write this declaration, and then in your code, there's a little bit of extra syntax, but this is the easiest way to do it. In your code, you then use library function, which is sort of being repurposed here. And you'd say library function of, and then you give it the name of the function you declared, and then you just give it some arguments, and it will go off and call it.
So nice. You need a library function decorator because the name of the function in the library is a string. You see, they might have underbars.
Of course, you need a decorator.
Yeah, fine. I'm just pointing that out. So, but there's a way of turning it into a symbol so that it's not, so you can write.
Oh, who cares? I mean, you just say SHA-256 equals library function of quotes SHA-256, and then you.
Well, maybe yes, except it might be in function, hold all code or something. We have a way of adding it to library function declaration that Christopher's got there.
Yeah, I mean, there's this syntax here. I honestly haven't used this syntax much, so there's some examples which I probably don't have time to show, but there's some examples about using exactly this stuff to. Like I made a link to like SQLite, which is like very, very efficient and produces all these nice, expressions as its output. Or actually, for Jose, I made this link to this package called Geos. It's a computational geometry thing, which uses this, and which is like, it was like an order of magnitude faster than the library link version.
And it was pretty quick for you to put it together. I mean,
it took me basically a day, but it has all the functionality of this thing.
What were the pitfalls of putting it together?
I can scroll over here for a second. Okay, so I mean, basically, I'd say there was still a bit of weird compiler stuff that I had to do, but I think if we go through the entire notebook above, that covers all of the weird compiler stuff I had to do, as in making it not weird. But basically, basically the way it worked is that. The way this Geos package works is they have a type called Geos geometry. And I wrote a big, long function that just took in expressions and would turn them into this Geos geometry object by calling lots of these library functions. And I had another function that took a Geos geometry object and turned it back into an expression. And then once you have that, then it's just a matter of, so I have this 2Geos that creates this basically a data structure that represents geometry. And then you can call from Geos to convert it back. And then in the middle, you can call any of these functions that.
So wait a minute, that output line that says type product, that is a representation of some raw set of bytes in memory. Is that correct?
Yes. This is a pointer.
Expression. Yes.
Yeah, this is a pointer. I mean, basically.
So what happens if you serialize it? If you say full form to that, what the hell is it?
It's going to produce.
You can add a full form to it, but in itself, it doesn't have one. So,
but what if you save this notebook, as you obviously did?
Yeah, you'd be hosed. You'd have to add a full form to it.
Well, wait a minute. Why isn't there a default full form for just these random raw?
There is a
let me explain the issue.
Right.
There is, but it's unuseful, right? So the point is that this cannot be automatically serialized. You could define a way of doing it, but like basically what this contains, it contains a pointer to a Geos geometry object, which is some object from this library that who knows what's in it, who knows how to construct one.
Yeah. They may not have a serialization for it, you see.
Right, but we could generate a serialization which contains the statement you can't serialize this or something. I mean, in other words,
we could do yes.
Because I think that would be useful, because people will want to save this stuff and then they'll be confused. It doesn't work. I mean, it's similar to what we have with all.
We have some things where you're not saving big outputs from NDSolve or something. So
I'm not actually sure. I'm not sure this has an interpretation.
So
I think it's something like, okay, when you call full form on it, when it's in the original kernel and stuff like that, I think it does something like this, which is sort of like a.
That's not very useful. Yeah, right.
Not very useful, but clear that.
I think it should generate messages and things. And I think, look, my suggestion would be, if it is going to contain pointers to random stuff which is session dependent, then it should be you should have something which is essentially it should generate a full form, but have poisonous pieces in the full form. Because it's the same issue as with data set, when the whole data set isn't being stored in the notebook, for example. Well,
Yes.
it's the same kind of issue. So it seems like we should have the same kind of solution.
Yes. Well, except what's the solution with data set? The solution is that there's a button
you're out of
to
luck.
store the whole thing, and otherwise it just doesn't work.
Yeah, you're out of luck. But the out of luckness is handled in a civilized or apologetic way as it can be.
Sure. Yeah. I mean, I think it should issue messages and stuff like that if you try and say X equals this type product, where this is from an old notebook and stuff like that.
Right.
But yeah. But in any case, I mean, it's fun because this link, because for example, right. I mean, you can do things like this is computing the intersection between the polygon for Europe and the polygon for Russia, and it takes it 1/10 of a second, which in the top level, if you just use the region functions, takes it like a minute. So yeah, I mean,
right.
Admittedly, this is making slightly different assumptions about the slightly different constraints on what sorts of polygons it has, like about self-intersection, basically. But other than that, yeah. So
that's really nice.
Right, but so the point is, as an example of how this works, though. So this is how you would define one of these functions. So here, if you have a function like Hausdorff distance, this is the C signature of that function. It takes two pieces of geometry, and then it returns an error code. And if it succeeded, it'll populate this pointer here with a value. I mean, this is an extremely typical idiom. And so the way you write this, using some stuff that we haven't got to yet, is first you have a library function declaration where you give it, the name, where to find the library, and the type signature, some of which also we need to talk about. And then the way you actually call it is you create a pointer, you call the function on its arguments, giving it the pointer, and then here I'm a little bit unsafe and I don't check the error code, and then you extract the value from the pointer, and that's it. And then this is a callable thing.
There's a few pieces that I don't fully understand, but we're probably going to get to them.
Yeah. Yes, there's a whole section for this. So yeah.
Let's see. Richard.
Right. So the point is, this is pretty. Sorry.
Richard has a comment here about serialization. For Richard, is this a comment you think it's worth saying something about?
Perhaps not at this current moment.
Okay, fine.
All right, so let's see. Yeah, I mean, so that's library function declaration. I think it's fairly uncontroversial.
That's really cool. All right, so let's leave. What's
the other thing about these library, they're very fast. So calling into these functions is much faster than library link. So library link. Why is that? Well, library link goes through a whole complicated state machine, even for tiny atomic functions, whereas this is, essentially a couple of, processor function calls.
Because can it crash? This can crash, though, as library link.
Library link can crash.
Right.
If you pass in, 0 and cast it to one of these GEOS data objects.
And there's no safety net that we can provide in modern times. I mean, so this is the same as it's been for 40 years, that basically the operating system just says there was a seg fault, splat, you're dead.
Yeah. It's the operating system protects your process, protects itself from your process. So your computer doesn't crash. But
I think that there might be, I've heard that there are mechanisms for sort of catching seg faults, but they're pretty limited.
Yeah.
So, yeah.
Okay. Wow, it's amazing that something like that has not advanced at all in so long. Okay.
All right.
Okay.
So the next thing is, right. So the in all these other earlier things, there are type signatures. These are basically some structures that live inside of type signatures. So the first one, so the first one is basically which may have a different name, is basically the one that you use for representing, it's how you deal with basically parameterized types, or it's how you deal with polymorphic functions, for example. So for instance, if you wanted to declare a function that, takes a list of anything and returns an anything, right? Like first would have that type signature. then this is the structure you'd use to represent the type of that function.
Or identity that takes anything and returns the same thing.
Sure, right. So basically,
write a function type with this, Christopher. That might be right, like identity or something.
Yeah, sure. So I mean, you'd have a. Well, okay, I'll just write it with.
Yeah.
Right. So the type of the function, I'll do first. So the type of the function first would be something like, for any t, and I'll do it for let's say packed arrays. I'll say it takes a packed array. We'll just do like the easiest case here. Basically a packed list, and then we'll return a t.
Right.
Okay, I understand. So this is normally if it was a literal thing. So okay, I get it. This is just a parameterized. Yes, this is a parameterized type.
Good.
Yep, I understand.
Right. So I mean, one of the things we talked about before was different possible names for this, because I think you didn't like the name type for all. Its argument structure is identical to for all, because it takes the list of variables and then the constraints basically if you want them, and then the type. But there are different options. So I mean, things like parameterized type, which I think is maybe a slightly more accurate for what it is, but a bit longer.
Yeah, and it's also, well, the fact that it's longer I don't think is an issue, but I mean, it's also unfortunate the argument structure is, as you say, exactly the for all.
Right.
I'm not sure.
But for all, by the way, for all also evaluates and does crazy things, so we can't use that either.
Yeah. No, I know.
It really evaluates. Yeah.
I just think type for all is like one of these, it's almost like a slogan of some kind. It's like I don't know what.
What's wrong with that?
Well, it's just a bit of a strange construction. I mean, it's hard to.
Another name which I think would be a little more consistent with other things would be for all type, because basically this represents a type, right? What kind of type is it? It's a for all type.
Yeah, I agree.
Right.
That seems more consistent with other things. For all type. I think that's better. I think that's better. For all type is better than type for all. What are the names of some other? Let's see. Could you remind me? What are some names for some other type-related functions? Type constructor.
Well, I can tell you about the
type specifier, which has type first.
Yeah, there's also this one that's right now internally called type literal, but should be literal type, because type literal. Yeah.
Well, let's see what it is.
So this was one that kind of came up a bit earlier. This is basically if you have like a packed array, of integer 64, 2, that expands out to this basically. And
what does that mean? I mean, okay, so I understand that there are literals, but how should I think about that in terms of type theory?
You should think about it as, types are like sets, and or maybe you could think about it just as, just as this is a named type, you could also have a type that's just named 2, right? I mean, there's no reason why strings are special. You could have a type that's just named 2, or you could have a type that's just named 15. And it's useful to have types with names like 2 or 15, because with type evaluate, which we'll see in a second, you can do arithmetic with them and stuff like that. For example, if I call first on a packed array, the result is going to be a packed array with a rank that's 1 less, right? So you need to be able to do arithmetic on this object here.
But many types, like integer 64, you certainly can't do arithmetic on.
Correct. Yes, correct.
Right. That's because it doesn't know. The whole point is that this is not, so, right. The type, basically, this is a number it knows at compile time. This is a number it does not know at compile time. That's one way you can think about it.
Is it always a number that it's dealing with in literal type?
It could be strings as well. So we support, in principle, it could be any other things as well, but we support strings and integers.
But so the basic point is that the thing that's inside there, type evaluate, will pick it up and do something with it.
Right. So you could have 2 versions of a function. So you overload functions, and then you can distinguish between the function based upon the type, and giving it a string name or an integer name to distinguish is pretty useful, actually. And you can pass these things around as terms in programs, for example. So,
okay, but the thing that causes something to be done on them is type evaluate. Is that correct?
In a
not
type
entirely.
signature, not entirely, right.
Otherwise, are they just inert packages? I mean,
They're inert packages, right? But you can overload functions based upon
the function can have an argument which takes a literal type and then
as a pattern type thing. But I mean, it could
because something like
could
packed
take an
array,
elephant.
yeah,
it can take an elephant there. It doesn't matter what it is. It's just a thing that is a literal expression match to what you told it.
Yes,
right.
Basically, yes. I mean, in fact, it's restricted, but yeah, in principle, conceptually, it could be anything.
Okay, but so the only case in which it's not anything is when you use type evaluate, and where you essentially strip the literal type wrapper and look at the expressions inside and do operations on them.
Correct.
Right?
Yes.
Okay.
Right. So really, the only reason why there has to be, the main reason why there has to be a literal type head that you see in the top level is because in the string case, it's ambiguous.
Yeah.
Right? Like if I write a string, hello, how do you know that that's a type hello or a type literal hello?
In compiled code, not in a type signature, in compiled code, it's also useful to use this. And then you absolutely need it to say this is a type, not a, not an integer.
All right, I get the
that's the other main reason.
What the right name is. It's a little weird that it's almost like it's a type constant or something. Is that a correct statement? That it's a
I mean, all of the types are kind of like integer 64 is also kind of a type constant,
Right.
So I think this is a type that whose name is sort of like defined by some literal value as opposed to.
What about type parameter? What about the wrapper being called type parameter?
Well, that would be very confusing if there's also I don't like that because up above we have things where when they're parameterized types, those take parameters, but there are other parameters that are not,
which are not wrapped.
Types.
Yeah, right.
Yeah.
I get it.
Yeah.
Okay. Also, literal type.
But by the way, just for reference, I think, like for example, in Julia, I'm pretty sure they have something like this, and it's called literal types.
Yeah,
I'm pretty sure. So I mean, there's precedent for the
TypeScript has something pretty similar, actually. So
okay, let's see type evaluate.
Yeah. Okay. So type evaluate. Oops, why is this not? There we go. Okay. So type evaluate, I mean, here's sort of basically it's you'd use it inside of a type signature, and you'd write something like this to say.
So that evaluates at compile time.
Yes.
As soon as it knows what concrete type it's testing, like if rank is 23. Then it will evaluate that.
I would have thought that this name should be more like type evaluation than type evaluate, because usually, evaluate is a do it now type function. Just a small point.
In
other words,
I mean, what do we call? The Asian ending. I'm trying to think what other things we have for that. I mean, other than like feature extraction or something like that.
Yeah. Those are things that usually are a thing. I mean, I just think type evaluate just sounds like it's going to happen now. Anyway, my suggestion would be type evaluation, although that isn't quite right either. But you see my point about that. You see it in the code here. It looks like it's going to evaluate now.
Yeah, maybe. Yeah, I mean, I think that this does, though. I mean, there is a sense in which type evaluate is like compared to these other type objects that are all kind of inert. This is like a much more active object. So I mean, I think it makes sense that it looks.
No, I agree.
More active.
All right. Okay. The small comment. I'm not sure what's right. Okay, let's keep going because we've got much to go through.
Well, okay, there's a bunch of stuff. I mean, I doubt we're going to get through everything here, but okay. So the first, so in terms of compiler language stuff, I mean, this is sort of a mix of, kind of semantics things and just like plain
the stuff
functions.
at the top here. How much has this allowed us? Like that sample code that I sent through yesterday. I didn't quite understand. I mean, is the end result that you can compile that or not?
So the code that you sent yesterday, the only reason it couldn't compile is because there were functions that the compiler doesn't know about, that it should know about, but it doesn't know about. I mean, things like complement and intersection and stuff like that. So if, the real solution there is just that there should be definitions of those. The sort of patchwork solution is if you wanted to write definitions of those, so the patchwork solution of basically you could write your own definitions of those, you basically can already do that. I mean, the thing I sent you only used top level constructs, but if you wanted to write your own definition of complement that was like a good definition that was actually general and worked on more than just, packed arrays of rank 1 and stuff like that, then you need to be able to use stuff like type evaluate, type for all, etc.
But so the basic point is, in terms of making the compiler work in the wild, I mean, are we ready to get people to actually go through and try and take lots of our internal functions, write the type declarations for them, and either feed into existing internal code? Presumably, we can treat the library link system, your library function code, and we can operate on the kernel that way using that. Is that correct? If we expose the kernel as a library,
we have.
Yes, actually, I mean,
we do.
Well, partly. I mean, there's the stuff that Chris Cooley is working on, which might make it possible to use like library function declaration to access a bunch of the I functions and stuff like that.
But Christopher, we already this is how we link to stuff. This is how, like, say, value kernel function is just a bunch of linking links to the kernel.
Sure, but there's like a list
library
somewhere.
function declaration because that didn't exist. But that's
sure. I mean, there's a list. There's a list somewhere of functions that are getting basically exported for the purposes of the compiler, right?
But they have to be exported explicitly from the.
I see. Okay, so wait a minute. So we need a curation effort going through the C code and figuring out what function hooks to export. Is that true? And then we need the other end of that, which is writing library function declarations.
Yeah. No.
So are we ready?
I mean, I think I think that depends on the. I think okay. To answer your question, are we ready for that? I think probably yes. I think the stuff about using I functions and stuff like that, I think I'm not sure. Okay, that's I think more useful in some cases than others, and I'm not sure. Like I'm not sure I've seen a case where it's really that useful because okay, so one case is it's a function like intersection, where basically the fundamental implementation of intersection is actually not very complicated. I mean, it's like it's a there's some algorithm, but it's like someone could write that from scratch. It's not really useful to call the I code because there will be overhead with calling the I code, right? There's another category though, which is where the I code is actually pretty useful, which is something like I'm dealing with a graph, the graph raw expr, and I want to be able to do all these low-level things on it. In cases like that, though, I think, right. I mean, I think in the near term, in cases like that, it's fine to just call the evaluator because if you're doing some big thing with graphs, it's sort of like
the evaluator or the O function. I mean, why go through the evaluator if you don't need to?
Well, there might be top-level code, but you could extract the pointer from the O from the symbol. That's the O function. Call it directly, of course.
Right, but I mean, what I'm imagining is that we have a wrapper that is the compiler hook for every built-in function, which contains both the type signature and the calling mechanism, which might be a library function declaration calling into O code or I code, and it might be calling a top-level piece of top-level code, which itself hopefully will be compiled. Is that a fair assessment?
Yeah, sure.
Yeah, but in many cases,
sorry, go ahead.
Yeah, I was going to say, in many cases, the O functions are not ready for something that has not been explicitly evaluated.
I see. Okay. But so, all right. But I mean, with a certain type signature, they would be ready. From the type signature, you could deduce if the stuff that's going in is ready.
Yeah, I think you
could
pretty much.
an inspection. Yes.
Right. But so the thing I'm looking at, I mean, as a practical matter, like the code that I sent through yesterday, or whenever it was, that should be
right. I mean, I think basically the effort of making it so that more functions are compilable. I think again, there are three classes of functions. They're the functions like intersection that are simple enough that they should just be written from scratch in the compiler because it'll be 5 lines. There are the functions that they're the functions that should definitely not be written from scratch, where I think maybe there is value where you could just call like if you're calling find shortest tour or something, some big heavy function where I think it would be okay to just call the evaluator. Mm-hmm. And then there are functions that are kind of in the middle, like vertex list, where it might be useful to be able to call an I function.
Right, but you're saying for the time being, just calling into the top through the evaluator is fine, but we still need type declarations, don't we, for all these functions?
Yes, that's the harder thing, to make sensible type declarations.
Right, but remember, it's not going to be perfect. We're going to have a best guess type declaration. Maybe it's a union. Or type sum, or whatever you're calling it. What are you calling type sum again?
Union.
Okay.
I think union is a better name. Yeah.
I mean, except we already have a thing called union, but anyway, never mind.
We also have a thing called product, and a thing called for all, and a thing called evaluate. But yes.
Yeah, right. But okay, but I mean, so fine. But the basic point is, I mean, do you yet have somebody set up to start going through and annotating system functions with their proposed, preferred type declarations? Has that happened yet?
The answer is no.
Okay, well, I think it should happen, shouldn't it? Aren't you ready to have it happen now?
I mean, probably. I mean, I think that the main thing is just that there's I think yes, ultimately, yes. I mean, the main thing is I think there will be a fair amount of decisions about,
Exactly.
like I did this example of making, trying to basically do this process for a bunch of graph functions. And there are a lot of decisions around things like, okay, what should the type of a graph be? Because a graph is, of course, it's a polymorphic type, right? I mean, it can, it's polymorphic. What type are my vertices? Am I directed or not? Because I have to know whether or not, when you call edge list, whether I return undirected edges, directed edges, some mixed list, etc. So there's a bit of, there's some slightly complicated stuff in designing those things. But I think especially once there's some domain like graphs have been kind of like designed and sketched out, like once you know what the type signature of a graph object is, then I think filling in all the functions is pretty simple.
So this is wonderful that we're at this point. I've been waiting for this for years. So, we need to get appropriate people mobilized to go and start doing these. And they have to be people who understand these functions pretty well. Mm-hmm. So we should break down, it's a project management thing, we should break down pieces of the system into different categories. And we should then, basically, I think this group, and possibly an expanded version of this group, should work with people who know these specific functions and try and get the declarations created. That seems sensible. I mean, I would say that the declarations for the things like the core language list manipulation functions, that's reasonably straightforward and probably is for this group itself. And there are things which are more applications oriented, like some of the math kinds of things that will require participation from those people. Is that fair?
Yeah, sure.
Okay. So we should make that happen. All right, let's go on and see the compiler language stuff. This is great. So, I mean, basically what you're saying is, but for a few names and so on, you are ready with this type declaration language.
Yeah, I think that basically the stuff that we've covered up above, once that's in, that's all that you need to be able to just do pretty much arbitrarily complicated stuff with the type system.
Okay, so fine. So that will be is it in the 13.1 builds?
Yes, but it's not in system.
Not all of it's in there, and it's not all in system context, but it's figured out how to implement it. Yes.
All right, so there are a few naming questions which still need a bit of grinding, but those can always be changed later. But I strongly think it's time to start people working on this.
So we can put these things in system context, write function pages, and steam ahead.
I think so. I mean, let's do one more discussion. Now that we've kind of gotten used to these functions, let's do one more discussion trying to grind the names and see whether there's any different naming we can come up with.
Yeah.
I think it would also be useful to actually get a bunch of examples, like pages and pages of examples of what people have actually done to try and write declarations for system functions. Because I think then it may be much easier to see when we see these things in combination, it may be much easier to see what reasonable naming conventions would be. And whether things which are glaringly blah type versus type blah look really horrifying when you see them in combination.
Sure. Yeah. I mean, I have some examples like that. I shouldn't pull it up right now, but I have some examples like that for doing the graph functions.
I think going back to the graph functions with the compiled expression would be that would be pretty useful actually. So.
Yeah. But yeah. All right. Well, I guess. Should we move on to the compiled language stuff?
Let's move on to compiled language.
All right. So this is more of a hodgepodge of stuff. So I mean, so one of the things, a lot of these are just like functions, because there's this relatively small set of functions that need to they're compiler specific functions. But I mean, this is sort of the first one. It's self-explanatory. So you have an object and you'd like to change the type of it. Some of the time. Right. Some of the time.
That third thing is the method of conversion.
Yes. Yeah. So let me. So two points. So the first point is that sometimes a cast, the sort of evaluator equivalent of a cast, is a no-op. So for example, I'm converting between a packed array and a list. That's a no-op in the evaluator, right? It looks like a no-op. But then there are other cases that are not as no-op-y that currently cast
like
supports.
Real to integer, for example.
Real to integer. Or even things like list to linked list, the linked list data structure, right? Those are not no-ops.
Yeah.
So there's sort of a mix here. But right, I mean, so those are this conversion cast. The other main one is basically bit cast, which is a little bit like the C casting function. It's like the low-level dangerous, the low-level dangerous
take the bits
thing.
And reinterpret.
Actually, in C, it merges reinterpret and bit cast. If you cast from an int to a double, a float in C, you get a reinterpret cast. But if you cast from a void star to a double star, you get a bit cast. So they're not the same things.
Sure.
And is this name right? Or should it be type convert or something?
Well, it's converting the thing to converting it to a thing of a different type.
What will it do from real to integer?
It'll produce an integer that corresponds if it exists. If it'll produce an integer that's corresponds.
I think it calls like round or floor or something.
Right.
It does kind of like similar to what happens in C.
Right.
But the bit cost of that would be something much more bizarre.
Yeah, absolutely. Bitcast, it's though you wrote it to memory, rename the memory to have a different type, and then read it back. You see,
right?
So you would expose the bit patterns, and the reinterpret cast, it sort of tweaks. It knows the bit layout of integers and the bit layout of reals, and it sort of tweaks them. So bitcast is zero. Effort. There's zero runtime cost.
Yeah, but it may produce complete garbage.
But it may produce complete garbage. Absolutely. Right. Correct.
Right. Now, I would kind of argue maybe that this is a different discussion. I'm not qualified to talk about, but I would argue reinterpret cast should be called something else, because my impression is that it's called reinterpret cast because there's an LVM intrinsic called basically reinterpret, which is what it's based on.
Calls it that, but it could be a different name. It's really between numbers, between atomic numbers. So
yeah, and it's really for converting like sort of more general number types to less general, like float 64 to float 32 kind of thing.
It can go in either direction. There's a definition.
So maybe it could be a different name. Number numeric or something. Cast with it, where that third argument is just numeric.
Yeah.
Right. Well, in any case, though, I mean, I think, right. I mean,
reinterpret number or something. Right.
I mean, in a sense, the first one is bits rather than bit cast. I mean,
right. So this is one of the other questions: is it could just be called bit conversion and reinterpret, but it's a little
raw
bit
bits
weird.
Or something.
Yeah, I mean, it could be raw, but then, yeah, sure. I mean,
raw bits will be fairly clear what it is.
Let me write these alternatives.
Copy those all down, Christopher. Let's have a look at them.
I'm trying. For some reason, my computer is running at like
2
frames a second. Yeah. I'm waiting for it to paste.
This is the Linux machine.
Wow. Yeah. No, I mean it's just because I'm sharing on Zoom for some reason.
Well, maybe Zoom is not properly supported on Linux. Who knows?
Oh wait. There we go. Okay. So this could be raw
bits
or raw bits. This would be convert. And this would be not reinterpret.
I would say
numeric. But some of these other ones also can do, like convert, I think can also do some numeric stuff. But I don't totally understand which numeric stuff.
Does do.
Yeah.
It does different numeric stuff.
Convert can also fail as well. And the others, like it can throw an exception. So
I think we need more precise definition of what these things are.
Yeah.
Okay, but that function seems uncontroversial. And it will evaluate.
3 arguments.
Right, but it will evaluate. So
you mean in the evaluator, or you mean right? So that's one of the. Right now, it does not. Maybe it could, but the thing I was saying though about the fact that sometimes it's not and sometimes it isn't is making an evaluator version of this is fairly non-trivial. I mean, especially for like the reinterpret cast cases, I'm not even sure that it's meaningful to have an evaluator version of that.
Why should you use the compiler? Then just run it through compiled code. Whatever the compiler does, go ahead.
Well, sure, but there's a certain like I wouldn't recommend that because it's sort of like the outer product of all of the well, I mean, maybe you could do that. I mean, there's a question of how many different. Well, okay, no, sorry. I'll give you an example where it's hard. Let's say I have right. It's like you have to look at every definition, every type of cast it can do, which there may be many of, like 1,000 or something. And then because fundamentally it's like an outer product, but it might be not fully dense. And then and then you also have to add on top of that. Well, what if I have a polymorphic type? What if I have a list, right? And now if I cast, if I have a polymorphic definition of cast, which is I can cast a list of T's to a list of S's, if there's a cast from T's to S's, then you've just multiplied your whole, set of casts by 2 and so on. But basically the problem is that if you want to compile like a polymorphic function,
I get it.
The way you have to compile all the different versions of it, and there might be like millions of these.
Well, I mean, look, you could do a hack, which is that you could compile at runtime one of these casts, and then you could store the compiled version for that particular type signature.
Maybe, and that might not be totally crazy because at least, I mean, if you're just casting between numbers and stuff like that, usually those things compile like fast, like half a second or something. But if you did try and compile like I'm going to cast to a linked list, that will take 20 seconds or something. So yeah, I mean, another thing, by the way, another difficulty is the fact that this is actually the more fundamental difficulty, is that in the evaluator you don't know what the type of object of OBJ is. Right, so you don't know, am I casting this from a packed array, or am I casting this from a list, or am I casting it, or whatever? And it might be a type that's quite. There might not even be a nice way of representing it in the type system, or there might be many ways of representing it in the type system.
All right, fine. So you're basically saying, for the time being, we understand what cast is if it doesn't evaluate in the evaluator.
Yeah, I think that's.
And maybe there's special cases that could evaluate, and maybe we don't have to worry about it for right now.
Yeah, I think so. I mean, I think if nothing else, maybe what we could do is for the no-op cases, do them, just have them be no-ops. Maybe in some cases, like passing from integer to real, it can call n. And then in any other case, I think it should maybe evaluate to like a failure and a message and stuff like that.
But it's pretty convenient for code composition, code construction, that it's inert and it doesn't evaluate.
I was going to say the same thing. That's
on the other hand, for debugging, it's a big pain in the neck that it doesn't evaluate.
Well, although if you're debugging it by running it in evaluated code, I think they're
probably out of luck.
That's pretty dangerous. But but also I would push back a little bit about the code construction stuff though, because it's sort of like, the only most of the time the only reason you can do sort of symbolic code construction, without having to worry about things evaluating stuff like that, is because you're using so many constructs that are these alien compiler only constructs. But if your program is using lots of evaluator constructs, then you're going to be
right.
out of luck.
We need a separate
anyway.
project doing metaprogramming.
The other problem with having it evaluate is it probably will work in a different way from in compiled code. When evaluated and compiled code can work in the same way, that's super useful. But this might behave differently.
All right. Okay. Well, fine. I don't think this is the most important point.
Yeah. Absolutely. Yeah. Right.
Okay. But I think the trivial cases should work just so that it's demoable what the hell it does.
Yes, I agree.
Okay. All right.
Okay. So the next ones is there's a little pair of to pointer from pointer. So actually, let me show. These are the usage lines. These are the sort of draft usage lines first, and then I have sort of C analogs of them up there. But basically, these handle the cases of I want to create a pointer. Basically I want to create like an integer on the stack that I can call some library function, and that function can populate that, as I showed the Hausdorff distance example before. There's some things about populating pointers that you're given and stuff like that. All of this is really only for dealing with external programs. You should never write this for anything else. But
so wait a minute, the pointer object thing is going to be something which is unsavable, unserializable.
Correct.
Yeah, it's not gonna right. I mean, I think that there's it's not.
Can I ask about one weird case,
which
is shared memory parallel computation? Is that a crazy case in which you want to send the pointer between processes, or is that just completely bonkers?
As long as that stack frame is alive, the pointer is alive. So
right, but I don't know whether we have any mechanism for that.
My guess is that if you want to do that, you'd have to use heap allocations anyway, which I think actually there's some stuff lower down that's sort of tentative and new about dealing with heap memory. But I think that the general concept here is that if you want to allocate something on the heap, you should just call malloc, which there will be a mechanism for, but it won't be beautiful. But it's basically like, we don't want to encourage people. We don't want to provide some mechanism for people to basically do low-level pointer management that's sort of very dangerous.
And doesn't get reference counted.
Counted, exactly.
Yeah.
Okay, so the pointer object is just something with a nice exotic. It can have some really exotic icon on it that suggests it's an alien thing. Is that fair?
You mean if it's return? I mean, it doesn't even have to be returnable to an expression. Like we could make it just like if you try and return a pointer object, to an expression, it'll just tell you I can't convert that to an expression.
Yeah.
Or it could, give it a fancy.
No, I think it should. You say here creates a new pointer object. So why not?
So I would argue that
if you return the pointer,
run it. Just run it. Two pointer. Just run.
It'll do nothing on the top level. It'll do nothing on the top level right now. I would argue. I've thought about this a little bit. I think it should probably intentionally fail on the top level most of the time, because it's like we really, really do not want to introduce.
Fine. Then its usage line shouldn't be what it is right now. I mean, it should say something like creates a new internal, represents the creation of a new internal pointer object.
Or maybe you could say
the current
compiled
function.
code.
in the current function frame, perhaps.
Something
yeah,
like
and it should mention that it only really exists in compiled code.
Right.
I mean, that just seems like it's a thing which you could just do with wild
Fine.
abandon whenever you feel like.
But do we
Sure,
like the
sure.
name, the name, to pointer from pointer? It's pretty nice, I think. Sorry.
So two pointer is a little bit of a pun also, because it has sort of, so okay, these are the usages with their C analogs below them, which I think is more understandable. So basically two pointer is, actually it's a little bit different. It's actually two pointer is this. It's basically saying allocate this thing on the stack and then give me a pointer to it.
Give me the address.
Give me the address.
Doesn't it need to know how big it is?
No, so the point is that it, well, by default, basically it can use, through the type inferencing, it will know what type it needs to have. So for example, if I for example, if I create a pointer with two pointer open close, actually, I can just show you.
There's an example. You've got an example there, Christopher. Example.
Right, right here. So the point is here, the argument, the third argument of Hausdorff distance is right now it's called handle. I argue it should be pointer.
Correct.
Is a pointer to a C double. And so you see that if we look here, I passed in this variable out and I created that with two pointer, but the type inferencer knows, because it knows, what this function takes. It knows that, okay, that's a pointer to a C double. Right. And if it can't tell, if there's a reason you can't figure it out, then you can use typed around it, which is basically the way of, annotating it and saying, I know you can't figure out the type, but you are a handle of,
right.
But
you hopefully don't need that, right?
Yeah, hopefully you don't need that.
Okay. Let me just understand this for a second. So two pointer creates just a memory address, allocating memory on the stack or what?
On the stack.
On the stack, yeah.
So it's like when this code is running, it will allocate that memory, and it knows how much memory to allocate because the type of out is something. No, what? How does it know how much?
Yes, yes, because it's because you're not right, because basically. Let me actually go down to this example here. It knows from type inferencing that the type of this object here is pointer to a double, right?
Okay.
And it knows how big a double is. So, yeah.
Okay. I mean, the thing that's confusing to me is that I would expect that two pointer, a thing with that name, would take an expression and return to me like an ampersand-y thing of that expression in some sense.
Right. Well, the problem is, the problem is that yes, there's a version of it that's a little bit like that, but it's subtly different. Okay. And it's because basically the ampersand operator in C does not make sense in the compiler. Like the ampersand operator in C sort of relies on the semantics of C in the way that C represents variables to work. And in the compiler, you can't just, if you have some object, it doesn't necessarily make sense to ask, what's your memory address? So basically this function, which is the one that's kind of like the ampersand operator, this actually kind of makes a copy. Like what it does is it, actually, I think I've written this example. I think this code might be slightly wrong. The point is that basically, if you say two pointer of v, x equals two pointer of v, and then you modify x in some way, you put something into x, that won't modify v, right? That won't make v some mutable thing, which is what the ampersand operator in C does.
So in other words, if it was called address of, then that's what you would expect to have happen. That if you change x, no.
Yeah. If you said address of, and then you got this pointer back, and then you told x, you use this usage to basically change the value that x points to. In C, that would modify v, but in here it would not, because this is a kind of a copy.
Yeah.
Okay. I think I need one more iteration of this, but maybe not right now. Let's just keep going for a couple of minutes here. So I understand.
Yeah,
okay.
So,
I mean, again, we should probably grind one more time on some of these names, but that seems like a good start here.
Yeah, I mean, there's also some things about the names of what the pointer type is called, but I think it should be pointer.
I think it should be pointer too. Yeah.
Oh, we could make it very long and pointer reference, but that's not particularly. Why do that?
That's a bit redundant.
Yeah.
It is total. Yeah. Total.
Okay. Okay. Let's just see.
All right.
A few of the other things. How much more is there?
Yeah. Well, I mean, there's some more, especially some long ones that I don't think we're going to get through everything.
I think we should cut those off. Yeah.
Let's just give us a little bit of a preview. Okay.
Okay. Well, so I'll preview of all of them or preview of one of them.
No, preview of all of them. I mean, just a rough preview.
So the rough preview is this one is about basically functions that take types. So there's a whole class of these functions that basically do things like, given a list, you want to ask it, what is the type of your elements, or given a graph, what is the type of your vertices? And so this is a proposed, hijacking of information to let you do that. Then there's type of. This is kind of a cool one, especially because it has good behavior in the top level. This is basically compiles a program and tells you what the type of its output is without running it. So for instance, here, I'm running this, and I think this will just work. And it runs pretty quickly, it takes like 1/10 of a second because it only compiles it up to the type inferencing phase. And the critical thing is, that echo is not echoed, but yet it knows what it's going to return.
Oh, no side effects. Right.
Right. And And this is super useful inside of compiled code because, for doing type manipulation stuff, that's super useful.
It's useful in top level. I think it's quite interesting in top level as well, actually.
Well, it's probably a good way to generate. If you're trying to figure out what on earth is the type specification for some random list somewhere. I mean, just type specifier of like the list 1, 2, 3.
Yeah. So I mean, this will, of course, this is, this is restricted to what you can compile. So
okay, but just the list 1, 2, 3.
But yeah, that should work. It's a packed array. Yeah.
See, look at that. That's really useful because I don't want to type all that junk in.
And I should be able to say, n of that, and it'll tell me it's a real 64 and stuff.
Okay, so just forgive me for a second. Just make the thing instead of the n there. Just make that a list of pairs, for example.
Like, you want to be rank.
Yeah, rank 2. But now my question here is, how does it know that this is supposed to be a thing of arbitrary length?
Because packed arrays are arbitrary length.
Well, it's true that this is a thing that needs to improve in the compiler anyway, that there are a few different types of lists. There's packed arrays for like arrays and matrices and linear algebra. There's list vectors, which is for if you want to have a list of dates or something. That's for basically representing lists, not packed arrays. Then there's also a thing that's right now called list tuple, but maybe that's an okay name actually. But basically it's for representing lists that have different types and different slots, short lists.
Yeah.
And right now those don't get automatically made, right? So this won't compile right now. It should compile, but yeah.
Right. So So when you're generating the type of in that line above there, you are making the minimal maximal type. That is a type which, that thing could be a list of 3 elements, each of which is 2 elements long, specifically. But you are assuming that it generalizes to be a list of arbitrary length and an arbitrary length list of arbitrary length lists, correct? But with integer 64s as their
yes and no. I think that would probably be a good principle. That might be a good principle for deciding these. Right now, it's pretty arbitrary. Because I think the basic history is that it used to be that this thing just only worked with packed arrays. It always did packed arrays. Now it can do some slightly different things. But yeah, there probably should be a principle like that for deciding how it picks. There might be some instances though where you might want to pick a less restrictive type. But for example, if we had a type, we might have some very specialized types that you don't necessarily.
So probably type of is going to get a second argument, which is going to be all kinds of information about what.
Well, there is an example. Well, you could put typed around things.
Yeah, I mean, so you can, of course, yeah, right. You can also tell it, for instance, right, you could write type. I mean, then it's not, type of isn't very useful, but yeah, you can tell it typed and then specify what the type of these is. But I should mention, I mean, type of also has a second argument where you can basically tell it about, you know,
Variables.
Assume that X is a real 64, or assume X is, because, you know, I might not have a real 64 on hand, but I want to, I mean, this is really for something like assume X is a geometry object, right?
Yeah.
Yep. But yeah. That's but okay, so I mean, we're just skimming these. So the next is right. So this we already talked about. Basically, if you do a library function declaration, you can then call it using library function. The other one is the entire C standard library. So the idea is that you can just call the C standard library by using library function.
Spectacular.
Right.
And how many
Another alternative.
How many more libraries should we do this for?
Lots. Lots.
Well, I mean, in general, lots. Yeah, I mean, in general, lots. But I mean, I think that the C standard library is one that's always, you know, it's always linked basically. So we might as well do it.
Not in WebAssembly. So not always.
Okay.
But shouldn't this have a name that says what library it is before you give the function?
Well, that goes into the declaration. So the library function declaration should have that.
Right, but I mean, as a generic thing, it's just like, look, this is very much like deep calling the Packlet symbol deep call thing for Packlets. See what I'm saying? This is like a deep call into this library.
Okay, so I think the thing is that, okay, so 2 points. I mean, first of all, is that there's the case where you use library function declaration, where you have to specify the location of the library and stuff like that. But the point is that this is a library function that just comes, it's always there. You don't need to declare it. It's an ever-present one. And so then one idea was to use things like external evaluate. And, you know, you could even do external evaluate, oh, it's from C and stuff like that. The reason why we don't do that is because these names are all super global because of the way that linking works. And so, right, I mean, there are no namespaces. There is no what library does this come from?
There are just names in the
I see. It's actually been linked. It's been linked. That's your point. In order to be accessible this way, it actually has to have been linked into the process.
Yep.
Yeah.
Right.
So I mean, so you might as well. I mean, we could have you write, you know, other things in here, but you might as well just write the name because it's the only identifier.
But the question is, if we're going to provide a set of standardly linked things, we probably need to curate their names.
Yes, definitely. I mean, so I think the C standard library is a
C types, right? The C types that we've done some curation.
Another one that's possible is the LLVM intrinsics. But I don't really know enough about those to know how much sense that makes. Otherwise, yeah.
Yeah, Rich is commenting about auto parsing of headers, which we have done some work on.
Yeah.
This was the original, you know, I like to say when I first got, you know, the first time I ever used the compiler for anything, like 3 or 4 years ago, it was because I wanted to do exactly this, of parsing C header files, because we have ClangLink, which can parse header files and give you the AST and stuff like that. So I think this is a definite target, would be to, you know, parse a header file, generate a big list of library function declarations, which, by the way, has to make some decisions about things like, oh, this takes a char star. Is that a list? Is that a byte array? Is that a string? Is that a C array of small numbers? You know, whatever. But it could automatically generate a big list of library function declarations, and then, you know, and then you can just call those using library function. But
right,
yeah.
All right, quick look through some of these other things.
Yeah. So some of these other ones, these ones we have to be really quick because these ones are the complicated ones. So, okay, so this one is about how there are some bits of functionality that it might be nice to, you know, let users modify. Yeah, basically, if you want to create a hook, so something like, oh, I have this geometry object, and there's a function that needs to get called when the ref count goes to 0 in order to free the geos thing. You know, how do I do that? I declare this function or whatever. So that's
these are handlers of various kinds. Yep.
Right. Another one is this is a mega complicated one that we really can't get into about expressions. Basically, right now, the expression type in the compiler is the kernel expr struct. But because it's in the compiler, its evaluation semantics are completely different, as in it doesn't evaluate.
It's like MC
right?
code, basically.
Right. So I mean, the point is, if I call reverse on an expression in the evaluator, I get this. If I recall reverse on this expression in the compiler, you would imagine that you get back this expression, right? Unevaluated. So basically the point is, this is super useful for writing efficient code, but it's also completely different from the evaluator.
Well, it is the meta case of the evaluator. It's the pre-evaluator of some kind. It's the thing that we have often wanted, which is the thing that handles unevaluated, that handles an expression without evaluation.
Yep.
Sure. Yeah. I mean, so the basic issue though is that if we want a definition of reverse that runs on expressions, in order for it to be consistent with the evaluator, it needs to return this, right?
Yeah.
But Christopher, it would be the 1+1 that would evaluate. It would be when you constructed the 1+1 that you would change. That's when that would evaluate.
Maybe so.
In this case here. Unless, but I mean, that's,
maybe so. Actually, I mean, there might be ways of doing. I mean, I think there's things with unevaluated where it might be subtly different.
Right. Or you have a comma, list a comma b, and then you do a = 3. And then you reevaluate.
And now you ask for a. Yeah. So I mean, I think the point is reverse does need to, So basically, the issue is there are a couple different options here. One of the options is to have two expression types, one that is basically one called expression, which behaves like the evaluator, one with a different name that's basically the raw expert type that doesn't evaluate unless you ask for it and stuff like that.
Talk about this.
This is a bigger issue. Another issue is how you construct some of these held expressions and stuff like that.
Yeah.
Then there's then there's an issue. I mean, this one kind of is a bit important, but I think it's not far enough along with the design to really talk too much about. But I mean, basically, this is about if you declare, for example, a type product, struct that you like. How do you actually instantiate one of them? One option is create data structure, but there are some arguments that, there's some arguments about why
for the purpose of having a thing to send to an external program as a raw collection of bits. Is that correct?
That would be a very common case. Yeah. I mean, there's some cases where that might be simpler than that, that don't involve external programs, but that would be one example. But yeah, so there's that. And there's a question about whether that's, whether it's distinct from create data structure, and if so, how to name it so it's clear what the distinction is and stuff like that.
We've not thought this through, so
we haven't thought that through too much. Then there's this unnamed thing that's currently called unmanaged, which is the thing about basically how to deal with rogue pointers and stuff like that, which is basically a way of, there are certain functions like for example, we have a type for C strings, and that's very useful to have C string, because then you might be able to, call string reverse on it, or you can ask for the string length of it, or, you can convert it to and from a string. So it's useful to have that type. But the issue, of course, is that, a C string is like this, is a pointer. It's this very dangerous thing, and you have to make sure it gets freed and stuff like that. So basically the argument or the idea is that we'll have some sort of object that's called like managed with or block or something like that, that basically you tell it, here's this object, and then I'm going to use it. And when the block ends, you're going to free this memory, and we can have a little bit of escape analysis to make sure that it doesn't, escape the block. But I mean, basically, it's just a way of forcing people to.
But nested
scope these
blocks.
things.
I mean, shouldn't you have the management tag be something associated with the block so that you can nest managed blocks?
I'm not sure what you mean. I mean, you could, with this syntax, you could nest them. I mean, basically, you're just saying
but
this is the list of.
How does it know that the unmanaged should be managed by the most the nearest enclosing managed block or the next managed block?
Well, because basically what you do is, okay, if I have some object which has type unmanaged, the idea is that you have a C string, but if you actually want to get a C string, you're going to get it and it's going to show up with this annoying wrapper. And all of your functions like string reverse aren't going to work on it because it's got this annoying wrapper. So if you want to actually use it, there's this function called managed block, and you give it basically this thing in its first argument. And what it's going to do is it's going to populate this variable here with a sort of unwrapped version of this, right? It's going to, so that'll be this sort of dangerous object. But because, I defined this in this first argument of managed block, it now knows when this managed block finishes, it can free that memory.
I get it. I hadn't really read this correctly. So that thing at the beginning is in fact precisely what I was thinking it might be, which is right. Okay.
It's this, but I'm not sure whether it should be set or rule or something like that, because it's unwrapping it. So it's not literally going to have this value. It's going to have some unwrapped version of that value.
I get it. I misread the thing. That's the sensible way for the managed block roughly to work.
Right. Yeah. And then as time goes on, we can write nice escape detection stuff to make sure that the pointers aren't making their way out. This name is wrong, and there are many different options for names. So yeah.
Okay, syntax for type specifiers.
Yeah, the very last thing. I mean, I don't really have much written here, but basically this is the thing we talked about before about having a different syntax. I mean, this is on the assumption that having strings for heads is too ugly, which I generally think it's pretty ugly. But on
the other hand, the type specifiers start to sort of build up massively if you nest a bunch of these things in, a packed vector array and a list vector and a hash table.
So left associative. So what you're saying is you want some kind of left associative operator form for type specifier. Is that right?
Well, I'm not sure what you mean by left associative operator form. I mean, basically it's just,
maybe it's right associative actually.
You mean infix form, but this isn't an infix form. It's because it has a brackets. I mean, this is the thing that we talked about a while ago. But I mean, the idea is just to have some sort of syntax so that you don't have a string as a head, but it's still
something with angle brackets is possible, because that's like templates use that.
Yeah, I mean, well, one option would be something like, well, the issue is that if you use actual,
you can't use actual. Maybe angle bracket colon, for example. Like
this, like associations, but with a colon.
For example, I mean, I'm just throwing that out.
Well, that doesn't quite work.
Yeah, that's not so right. Sorry.
Right. I mean, there's many. That looks like a squiggly arrow of some kind, so I don't think that works. But I mean, so there's a lot of different options. It's unclear what
Okay, but the basic point is, this is a thing that should represent. This is the syntax for type specifier of packed array, and then curry
compound types. Yes.
Right, and then curry in that thing.
Right.
And but you want it, don't you, to be able? Don't you want it to? Do you want it to do another level of currying or not? Or is that the only level that you need?
You mean? Do I want it to be this?
No.
You never want.
I don't think so.
I don't think so.
Okay, so it's just one level.
Yeah. And the other thing that's nice is that this could have a nice. So another advantage of having basically having some nice syntax as opposed to having strings for heads is that means that this object will actually be a type specifier, and it might have some prettier formatting or like syntax coloring and stuff like that.
Which probably should follow whatever its pretty form is, should follow visually whatever the thing is that is the the ASCII way to type it in.
Sure. Yeah. But I mean, you can have colors is the main thing. But yeah.
I mean, the problem, and we need at least we need an opener and a closer, because we can have an arbitrary number of arguments here.
Correct.
Yeah.
unless we have an infix form and then those arguments are in a list.
That's a little weird, I think.
I
Because these things are really, the type is taking arguments, right?
Right.
It's really like a function.
Also, we use lists to represent function arguments as well.
That's true. Yeah.
Can I understand if you had, for example, at open bracket as the initial thing, do you need a closer that is matching with that, or can you just determine it by close brackets? Or am I?
I think you can just determine it by close brackets. I mean, because it's just that, you know, you just count the number of open brackets and you know which close bracket, you know.
So your form there with colon would actually work.
Yeah, I mean, I think this is a parsable thing. This might even it's a syntax failure right now.
I mean, colon is massively complicated in the parser. We have to think very carefully before we commit to that. It might not be implementable. Colon means a bunch of things already. So
indeed, it does. But I don't think it means.
And adding another thing might be a step too far. Maybe it'd be okay, but
this is an implementation question, though, right? Not a syntax.
Conceptually, this seems quite
not implementable. That's more than an implementation.
Well,
question.
what about colon?
Well, that means something already.
That means something different. I mean, I know that, but single colon means something. But yeah, let's see. I would kind of question it a little bit. Well, actually, you know, in at least in Rust, colon basically means the same thing. Yeah, but that's a little bit crazy.
Well, I don't think it's bad because I think it is very exotic looking, which I think is good because we don't want a syntax which people could type, which elementary users could type by mistake.
Yeah. I think the colon that probably is implementable.
Yeah, okay. Well, maybe that's the thing then. I mean, you can see the syntax highlighter is struggling a little bit because it thinks it's a message name. But,
because it doesn't know about it. Right.
That seems like the most plausible. And it seems like it's exotic looking, but it's not, it's exotic and alien, but it's not completely incomprehensible.
Yeah.
Right.
Or angle bracket.
I don't think angle bracket is the right thing because in the end, it's going to be a brackety like kind of operation. And I think angle bracket, unless it's something like an association type thing,
the thing I'd be scared of is the close bracket is going to.
No. I didn't mean that. I meant angle bracket, open bracket. Get rid of the double colon, like that.
I think that's going to look a bit like associations.
Yeah, probably. I quite like the non-symmetry, the colon open and close. That's kind of interesting.
Yes, because it's basically saying. That's my preference from these is the colon open bracket.
Okay, I'll have a look at that in the parser.
Fine. Well, this is wonderful. Was there anything else in this notebook? Just to.
No, I mean there's the geo stuff, and then there's also a SQLite thing, but it's similar to the geo stuff.
This looks great. So when can we really, get lots of? I mean, because I just want actual code in the wild to compile.
Yeah. I mean, I think at this point it would make sense. We could have people just working on trying to just go down lists of functions and make them compilable. I mean, I think that's fine. I think that's plausible.
So are we ready? Then let's Aubrey can get going on actually following up on that.
Mm-hmm.
Okay. Okay. Well, interesting. It's very, very nice. And this is, and you say you can get this into the system context in 13.1.
Yeah.
Or what you've looked at.
So most of it. I mean, there's most of the things that we talked about. I mean, basically, all the declaration stuff. Pretty much all the declaration stuff is either in or will be in like a day, 2 days.
Yeah.
Some of this type stuff, this is basically in, except they need to move to system, and there's some probably name changes like for all type or literal type. These ones are in, they just need to move to system. and get documentation and stuff.
Same there.
You know, same with this one. Yeah, I mean, it's only really the stuff about some of the stuff about basically the stuff that we didn't get to properly, like with expression and things like that. That those are the things that are still a little bit.
Right.
All right. So we need a follow-up meeting.
Yeah, we need to think about the library naming business. That's needs thought.
That might be a different. I mean, that might be good for like an LCC meeting or something. I would argue the thing about making find library a bit less dumb.
Yes.
Right. I mean, I looked at that a little bit, but it's actually a little bit complicated because, for example, one of the things that would be nice is, you know, basically the idea is to have some sort of list somewhere. Maybe it doesn't even have to be user exposed, but some like association where basically you can tell it, you know, oh, you know, open at the name quotes OpenSSL, that's libcrypto, and you can search for that on the path. But then the issue is that, you know, the first issue you run into is that, well, OpenSSL is actually two libraries. It's libSSL and libcrypto. You need both.
And they have different names on Windows and Linux and Mac.
Yes, they do. There's only one library on Windows, I believe. And but then also that means that, well, if find library returns that, then load library also needs to be able to accept a list because find library might return one. And then, you know,
all right, you know, more stuff to figure out. Okay.
Yeah, exactly.
Absolutely.
Okay. Well, this looks really good. I mean, this is wonderful progress. I mean, let's why don't we plan a follow-up meeting, preferably within a week or so, to go through before at least I've forgotten what all the issues were, to go through and dig into a few of these other things that were in the later part of this agenda.
Great.
Yeah. Sounds good.
Good.
Okay. Thanks a lot. Thanks to folks on the live stream too.
Yep.